Hi, in this video we're going to talk a little bit about data visualization in general, and then why I think the ggplot2 package within R is basically the best option as far as I'm concerned for all of your data visualization needs. I guess we'll start with just a bit of an overview of what's the purpose of data visualization in the first place. Why are we making graphs and charts and clever little tables and so on? Essentially, we're trying to get from data to information. So if we look at our data set here on the left for the GDP of the UK over time, we see some numbers, but it's kind of hard to make sense of what these numbers really are. I guess if we stare at them hard enough, we can pick out the story, but as soon as we put them on this chart, we immediately get the full picture without really having to think about it too much. We can see up to 2007, the GDP is growing, and then suddenly there's a big financial crash in the middle. All of that same information was there in the data, but looking at the graph just helps it come immediately clear. You get the expression that a picture tells 1,000 words. A graph, if you want to, can tell 1,000 numbers, more than 1,000 numbers potentially. Overall, there's probably kind of two categories of purpose for data visualization. You read books and these get categorized as being exploratory. So these would be the kind of plots that you would produce for yourself while you're exploring the data to try to understand different patterns and trends within there, identify values that look a bit odd, if there's maybe going to be issues with how you're planning to do a more formal analysis of the data later, if there's a strange distribution or other factors that you weren't necessarily going to take into account in your analysis seem to be perhaps important. So when we're thinking about our requirements for what software we want, when we're thinking of doing exploratory plots, we want something that can do lots of different kinds of charts and graphs and is really flexible in how it produces it so that we can modify our plotting style, add things in, change things, look at it in a slightly different way. So it needs to be quick and easy to use so that we can fully not waste time on spending 3 hours just to make a single graph. We want kind of the default options when we make a chart to be pretty good default options. We don't want to have to do too much tweaking to understand what's going on. The other end of the scale for purpose is what gets called explanatory plots. And these are essentially plots that you're not making for yourself, you're making for an audience. When we say audience, immediately your mind goes, okay, I'm giving a presentation and I want a graph, or I'm writing an article or a poster. But even something as simple as just sharing a graph with a colleague that you're working on with a project, you need to be communicating something in the graph because whoever your audience is doesn't have the same context that you do. And you want to be quite clear with your presentation to communicate the patterns and trends which are making up your argument, whether it's an argument in an email or whether it's an argument in a presentation or an article. We want to be highlighting the interesting results in the way that we present the data. And it should be complementary to the statistical methods used as well. And there's also a kind of extra requirement that we would quite like it to look nice. At this point, this is something we're sharing with someone else. So we want to be like, yeah, this is a really nice looking graph. I've thought about how I put it together. I'm making good use of colors and labels and everything is nice and clearly presented. So our requirements here are much more about having the control to fine-tune lots of different aspects so that we can come up with something which is really clear and looks really nice. Obviously, when we're making graphs, there's a lot of overlap between these two categories, and there's lots of different software already on the market. I'm sure everybody watching this presentation right now has probably made a graph at some point, probably using Excel. I don't know how to make graphs in Excel. I don't understand how Excel makes graphs. It's very complicated and confusing for me. But lots of people find it easy, apparently. Okay. Other options, I guess, are things like SPSS or Tableau, which are quite easy to work with and quite easy to change and fiddle around with different options. If you're making like a really high quality presentation graph, infographics and things like that, you'll often see people using much more bespoke graphic design software, things like Adobe Illustrator or Inkscape, to have really, really fine control over how everything looks. In the middle, you've kind of got your programming language approach to making charts. So Python, MATLAB. As far as I'm concerned, though, there's a clear winner, and this is ggplot2 within R. For me, the main advantage this has over over MATLAB is you can just make the graphs look better than you can in MATLAB. MATLAB's charts look a bit ugly. And over Python, the big advantage is that Python has lots of different plotting packages, which means you kind of have to learn lots of different plotting packages. Whereas with R, there is just the gold standard, which is ggplot2. And all of the development and exciting innovation kind of goes towards ggplot2. So it's much easier to pick up and learn and then extend all of those skills using ggplot2 than it is with any of the Python plotting libraries, although some of those are also good. One of the first things that people tend to ask when they come across this for the first time is, what is ggplot2? So the GG comes from the Grammar of Graphics, which is this book from 1999, which kind of formalized a system for breaking down all possible graphs and charts into a consistent language. We'll talk about this more in a second. So this came into R in about 2007, was when the package was publicly released for the first time as ggplot2. There was a ggplot, but it kind of was a glorious failure. So the author of the package, a guy called Hadley Wickham, kind of just left that to one side and said, okay, let's start again. And so that was where ggplot2 came from. And this has now grown into probably the most widely used R package, or at least one of the most widely used R package is. And this is a component of what's called the Tidyverse. So this is a whole set of different packages for R. And what's quite nice is there's a bit of quality control in the Tidyverse set of packages. One of the biggest advantages of using R is that anybody can write a package if they see that there's something missing from R or some kind of technique that they want to make easier for other people to do. One of the biggest downsides of that, though, is that anybody can write a package for R. So they're not necessarily all of the same quality. They don't all necessarily work nicely with each other. Whereas all of these packages which are in the Tidyverse, so ggplot2 and Dipler and Tibble, I guess are the three that we're going to be talking about a lot in these videos. These are packages which have a level of quality control and they have a level of consistency, which is very nice and very useful to have. You're not worried about trying to learn something in a slightly esoteric way. So ggplot2, like I said, it came into R in about 2007. That doesn't mean that plots only came into R in 2007. There have always been plots in R. You have the base plotting library as well. I don't think, as a new user, it's really worth worrying about how the base plotting library works, because ggplot2 is effectively the standard for all people who are using R these days. Also, it's not as good, and that's why ggplot2 is the de facto standard. So a lot of courses aimed at beginners to R, they will teach you all about these base plots first. I don't think it's worth wasting your time learning how these base plots work. Let me just explain why a little bit. So here we've got an example of two plots made in R, one using the base R package on the left, and one using the ggplot2 package on the right. This is the same data that I had earlier in this video with the line showing the GDP of the UK over time. If we just look at the plots, the one on the right initially looks a little bit nicer than the one on the left, but there's not really that much in it. It's just a little bit cleaner. But we look at the code for this particular plot, and yeah, okay, maybe the base R function is a little bit easier to see what's going on. Okay, we're saying plot, we're saying put this on the x-axis, put that on the y-axis, type equals L for line, yeah, I guess that makes sense. The ggplot2 code, we look at that on the right-hand side, and it's a little bit more complicated. There's a few weird things going on. We see an AES, I can't immediately think what that means. We see geom_line, that seems like a bit of a weird way of saying doing a line plot, but okay. So to begin with, if we look at this very simple plot, maybe we don't mind the base R approach to this. It looks a little bit more straightforward. But then we show this to our supervisor, and it turns out our supervisor just hates lines. They like bar charts because they think bar charts are cool. I mean, they're wrong, but they think bar charts are cool. So they say, do a bar chart. And in base R, again, it isn't too different in terms of the appearance. The big thing that I really dislike about the base bar plots is you don't get axis labels by default. That's a bit annoying. But then you look at the code and you see that the code has kind of changed quite a lot for the base R plot. It's a different function. We're now using bar plot rather than plot. But we're not talking about X and Y. We've now got height and names.arg, which is a bit odd. The ggplot2 code, you probably notice this has more or less stayed exactly the same. The only bit that has changed is it's gone from geom_line to geom_col. Otherwise, the code is identical. Then we realize, okay, we don't actually care just about the UK. What we really want to do is we want to compare the GDP in the UK to the GDP in Ireland. So we're going to have maybe two sets of bar plots side by side. And then we get something that looks like this. With the base R plots, sure, this is possible, but it's really not pleasant code to get to that point. It's possibly a slightly easier way of getting there than the way that I've written here, but that's more or less the most straightforward way I could think of to make this particular plot. I would not recommend as a beginner trying to interpret what on earth I've written there. With ggplot2 though, look at that, it's just one extra line, quite simple, quite short. Again, there's a bit of weird terminology in there, but all in all, I'm definitely preferring the ggplot2 approach right now. One of those things that does put people off, though, from ggplot2 when they're coming to it as a new user is there is a lot of terminology, which is either words that you've never really come across before or words being used in a slightly strange concept. And then you come along and check the documentation, and one of the first things you read is this sentence here, which is, it's hard to succinctly describe how ggplot2 works because it embodies a deep philosophy of visualization. Which sounds pretty jargony and nonsensy, and again is not necessarily the most friendly sentence to be coming across when you're trying to pick this up for the first time. I don't think it's as highfalutin and deep and philosophical as it's claiming right there. Maybe I'm going to fail miserably, but this is my interpretation of exactly how ggplot2 works. And once you've got the hang of it, you'll see just how powerful it is for being easily able to make more or less any plot that you can think of. So like I mentioned earlier, this idea of the grammar of graphics really gets at this question of what is a graph, and it tries to deconstruct it into all of its different elements. So let's take the plot that we ended up here with our bar charts for the GDP of Ireland and the United Kingdom. What are the different elements within that? The first thing we've got is underlying all of it, we have the data that we're using. Everything is coming from the same data set. And then we're thinking about, okay, within our data set, which variables are we using and where are we putting them? So we're putting the GDP on the y-axis and the date on the x-axis here. Then we're thinking about, okay, how are we plotting them? In this case, we're using these different bars to represent the GDP values. Previously, we used a line to show the trend. Here we've also got different panels for different groups. We've got Ireland on the left and the United Kingdom on the right. We've also got how far the axes are extending. So on the y-axis, we've got it going from 0 to about 70,000, and the x-axis from 2000 up to 2016. And then we've also got those little fine details of, okay, we've got grey panels in the background, and we've got font, which is reasonably small but not too small, and what colour the font is a slightly dark grey, and all those little fine-tuning details for exactly how the appearance comes apart. And those 6 elements are basically the 6 core elements which make up this grammar of graphics. There are a few others on top of this, but these 6 are definitely the most important ones to be learning about to begin with. And just with these 6, there's so many really powerful things and really useful things you can get at once you've got to grips with what's going on. So again, the terminology is a little bit strange, so it's worth repeating it and getting used to it, where we've got the data being used is what's called the data. That one makes sense. This is a slightly strange occurrence. But then when we're talking about what variables go where, this is the aesthetic mapping. The type of plot we're making, this is what we call the geometry. The different panels for different things, this is where we're talking about having facets. And the axes extending as far as they do, this is where we're talking about scales. And then all of that general fonts and colors and backgrounds, this is where we're talking about the theme. So let's focus to begin with on just the first 3 of these 6 components. Because with the data, the aesthetic mapping, and the geometry, these are the 3 which are essential. These always need to be specified. Everything else is to a certain degree optional because there are defaults which it can take, but without data, aesthetic mapping, and geometry, we don't really have a plot. I guess that's not strictly true, because we can write a perfectly valid piece of code in R, which just has data in. So we can write ggplot2, open brackets, data equals GDP. We've got our data here on the left, and we get an output, which is just a big grey square. We've told it the data set we're using, but we've not given it any other information about what to do with this particular data set. So you can run this, you don't get an error, you get a lovely grey square, but we probably need to do something else. And this is where the aesthetic mapping comes in. So this is the part of the code where we say, okay, which variable do we put on the y-axis? Which variable do we put on the x-axis? So the GDP, we're saying put that on the y-axis. We're saying map that to the y-axis. And the date, we're saying put that on the x-axis. We're saying map that to the x-axis. And the x and the y, this is what we're considering as our aesthetics. We're going to learn about a few other types of aesthetic later, but the main ones that you will always come across, or nearly always come across when you're making a plot, is y and x. And we specify that aesthetics within that ggplot command. So we have the AES for aesthetics command, within the ggplot command. So make sure when you're writing your code, you close 2 brackets at the end. This is something which catches people out all the time. Again, by itself, the output of running this line is perfectly valid, but it's not very useful. We just have a set of blank axes. But we have effectively the blank canvas on which we will later be putting our particular plot. So you can kind of see already this has done something a little bit useful that we can then build on. And the way that we build on it is with the geometry. So the geometry is we're saying how exactly would you like to plot the data. So if we would like to plot it with a line, then we're going to use a line geometry. And all of the geometry functions in ggplot2, they're of the same form where it's geom underscore the name of that geometry. And the name of the geometry for a line plot is line. There's a few little quirks with how the code is specified here that you might have not seen before as well. So because ggplot2 works with layering, it layers things up. We specify this through a separate command to that original ggplot command. So you can see at the end of that first line of code, we've put a plus sign. This means we're adding an extra layer at the end of that. The first line is setting the base, the canvas, if you like. Then we're adding the plus, and we're going to add a layer on top of that, which is going to be the line. And as we'll learn more about ggplot2, we'll keep layering up all of these commands. So make sure you remember to put that plus at the end of the line when you're writing the code. Again, something which catches a lot of people out here, where they'll miss a plus in their code, and you'll get something slightly strange. You don't necessarily get an error, because you still get a complete plot being made. It's just not the plot that you thought you were making. Second thing is you can see with geom underscore line, we've just got an open brackets, closed brackets, but nothing in the middle. So when we've seen functions before, we've normally told it something. And here this is because geomLine is a function, but at the moment we're happy to just take all of the default options. So we still need to open and close the brackets so that R knows it's a function. But if we're happy with, the width of the line and the color of the line and whether it's a dotted or a dashed line, we don't need to change anything here if we just want a line which is just a standard width and black and just go straight on. So that's why we have the open and closed brackets for geomLine. Once we've got this framework now, as we saw earlier, we can switch to a different kind of plot just by changing that geometry. So if we wanted the bar chart that we saw before, we have geom underscore col. So sometimes the name of the geometries are not necessarily the most obvious. So geom bar is a little bit different to geom col. Geom col we use when we are specifying the x and the y value. Geom bar is a little bit different. We'll learn more about that in a later video. Col here is short for column, which again is not necessarily immediately obvious. there's a very helpful cheat sheet on the RStudio website, which goes through all of the different kinds of geometry which are possible to use in ggplot2. And one of the other things that shows is, because when you have different kinds of data, you have different sorts of plots, different sorts of geometries available to you. So here in this case, we have a number, date, on our x-axis, and we have another number, GDP, on our y-axis. So here we could use geom_line, or geom_point, or geom_col, or geom_step, or geom_smooth, or geom_label, and all of these would be valid ways of setting the geometry here, because we've got an x set of coordinates and a y set of coordinates. However, let's say we had a slightly different setup. Let's say we had data on gender and income. And here it's a little bit different, because gender in our data is a categorical variable. And so the range of geometries available to us is a little bit different. So we could still do point, geom_point would still work here, but say geom_line or geom_col, they wouldn't necessarily work. Sometimes they might not give an error, but it will come up with a slightly strange looking plot, which was not what you were expecting. So here things like a box plot or a violin plot or a jitter plot, these would all be valid ways of looking at it when we've got the categorical variable and the numeric variable. Again, that ggplot2 cheat sheet is very, very useful for seeing the different geometries and seeing the different data requirements for what you need on the x-axis and what you need on the y-axis. So just to sum up those 3 key points from this session, if you've got data and you're mapping your aesthetics and you've got your geometries, with just these 3 components, if you start to see how it all fits together, you can suddenly build a full range of all different kinds of plots by setting from your data different variables and different types of plotting. And when you're coding it up, remember just those few little quirks for how ggplot2 works, where you have your aesthetics function, which is nested within the ggplot2 function, and then you have your plus sign to separate the different layers. And make sure that if you're just happy with the default options, you remember to have geom_line, open brackets, close brackets. Remember those to open and close brackets. Hopefully that's given you a good overview of generally how ggplot2 works. I suggest you start kind of working through and practicing for yourself some of these ideas and techniques. Again, just reinforcing some of this strange terminology, which I know catches people out all the time. And then in later videos, we'll start extending this and learn more about different kinds of aesthetics and how the scales and facets and themes all fit together very nicely.